Thank you so much, Stanford's Graduate School of Business, for this opportunity to share my doctoral research with amazing audience here and business leaders who can actually help me build the industry that is going to change the world, I hope. So the three takeaways, let's begin with the end in mind. First is autonomous technologies are emerging and they can save the rural landscapes and address the problems in the rural landscapes and literally build the whole new ways, the whole new skyways. Second is we need to create a whole new industry. It's not going to be about one company, one product, one hardware, one software. It's going to be much bigger than internet. And third is India is a great place to build this because we have so many rural landscapes and half of the world's population lives here and half of that is in rural landscapes, which we can make a big difference in. My background, quickly, this is a village that I spent my first 5 years of life in the middle of Maharashtra, heart of it. My husband is from the similar rural village where all 10 grades were in one classroom. We didn't have access to video games or the other tools that advanced people have, but we had access to paper and pencil. So we fell in love with numbers. That led me to actually win gold medal at the state of Maharashtra and then 765th at National Talent Search Examination across the whole India. Became a software engineer, which is first class honors. That puts me into 0.001% of the top software engineers India has produced. I was told about this when I was hired in Singapore Airline. And ended up doing my MBA from heart of Silicon Valley and super excited to be part of GESB. I think you all are part of SEP community now. And I'm so excited that I actually ran into this program last year. And I really want to work shoulder to shoulder with all of you to build this whole new industry. It's about perspective. That's what Sarah said in the beginning, right? So to get the perspective of the altitudes, I actually learned to fly the aircraft. My examiner, DPE, decided to help me take this photo because I ended up landing the plane in all emergency scenarios exactly where it should go, which was like amazing. What basically all these perspectives leads to is the environmental and emotional sustainability issues that exist in rural landscapes. If we want to change them, we build up the road networks, make it everything urban, and we try to solve the problems. So there is a huge number of people moving from rural to urban areas, and that's actually about right now half of the world's population in rural areas. So it's not too late. Urbanization leads to lots of issues with fuel consumption, high cost of building the infrastructure, and all of those can be prevented for the future if we use autonomous effectively. And why India? Because half of the rural population, you can see the concentration, they live in India. So the extreme challenges, just giving you 2-3 examples. This is a screenshot that I took at 19,600 feet. It's the highest heliport in the world in mountain range of Andes. We still had 4,000 more feet to climb when I took this screenshot. There is no healthcare. There is no supply chain. If you fall sick, there is no help there. So the technology has not been able to support supply chains especially if there is a lower demand because it's so expensive. This is another. Anytime issue happens, we say, hey, it's because of the weather, the flight is delayed. Followed by another issue that, hey, computer systems fell down. This is a challenge that I'm explaining. You see that mountain behind me, that's about 7,000 feet wall in south of Aconcagua. And at the top, you see the mushroom cloud. It's about the same height. So that tornado is basically a snow tornado with 100 miles per hour wind. And we actually have figured out with the technology to predict when it will dissipate. And then you can time it so that you can summit. So the idea is weather has a certain number of variables, and we do have technology that actually we can work with and use data to actually summit in toughest situations. This is the interesting one for the business mind in me, which is economic feasibility. In 1960s, airtropolis concept started where actually the first few airports were built in America, and FAA came up with how different road networks will work and the economic systems put in place. then that's extended all around the world. But if you try to take that to the rural landscape where there is no airport, the cost is pretty high to build the infrastructure. And that's why there's also a migration happening. So there's a lower demand of products. So that combination makes it impossible to use these landscapes moving forward. So if we don't do something, we are going to be using a fraction of urban areas for living. So the multiple altitude strategy actually came up because I'm doing my doctorate research and I'm looking at how technology helped at land. So first call center for India in 1998, I was part of that project challenging Jack Welch. Why are we using Six Sigma in manufacturing for quality? Why not think about customer perspective? That's the first CRM software. Palm 5, world's first mobile application in US in Mountain View, California, was designed to deliver internet in your car. PayPal, digital payments, not only on the websites, but we started using them anywhere, anytime. And then the latest medical innovation is molecules from your skin can tell you the sugar content, and then you can actually do the diabetic treatments on the fly. G7 is not going to be deployed in India anytime soon. The most innovations stay in US for a reason. The next, so I was pretty happy being on the land, but as I started flying, I realized that there is something that we're not using. We're not using the airlines as effectively as we can. Hypersonic, supersonic can take you from India to US in 5 hours, but we don't have those anymore. And as I learned more, realized it was not because the technology is not possible, but because of the decisions made in 1960s in terms of what is most effective way in terms of cost benefit. The next altitude that I'm currently working with is Blue Origin, which is we take the human flights up, again focusing on the humans, to 64 miles. We also have software, but again, that software includes Subversion, which was developed like 1980s. And the next one, I had been fortunate enough to involve in the conversation about orbital reef, which probably is set to replace the ISS when it sets down. And all of these altitudes have a different set of software tools, but all of them are very, very, very old. So if you're going to do machine learning, for example, you don't really need wireframes, A/B testing, or any of that. You don't even need an input-output from the mouse. It was designed for a computer. So if we can create this software stack that actually can work across multiple altitudes and the hardware is designed to work with them, instead of 1960s constraints of fuel, road networks, airports, it will be a game changer. And actually, we can also work at the altitudes that are below sea level because we already have drones that are waterproofs. But right now, the software is a big issue because everything about software is with human in mind. When you click on your phone, getting the request to response and coming back to you with a response on your phone involves about 200 hardware components across the network. And it also involves thousands of jobs who have created it. And all of them are about to be obsolete if you want to go autonomous. So I want to define autonomous before I conclude because autonomous is not AI. So this is one example, beyond line of sight. So traffic maps have been used in terms of the radar system where the air traffic controller gets involved, and they were designed in 1960s. But recently, FAA gave approval to something called Sound AI. The airplane can have microphones, and it can listen to the sound and create a map on the fly and then decide and navigate collision possibilities. I think this is a drone company, a real use case proven, and just got approval. But that is what I meant by autonomous. Autonomous goes beyond just using cameras. It's just the data. So what we are trying to do with LLM is take the data, turn into a language, process the language, turn it back into data. But if you want to drive a car, you need only 2 outputs. Steering wheel, the shape you want to turn it in, and the gas pedal, right? But to get to those 2 data points, we have been spending so much cycles and energy. So Sound AI is one example of autonomous. Data can lead to the data actions. The second one is actually there is no need for airports anymore. So this particular aircraft can land back, talking with the software to the hook system, So when the plane comes in, the hook will just shoot and hold the aircraft and it will stop it. So you don't need an airport. Imagine that you can have a flying machines anywhere that can stop. And it's just one of the innovations that's autonomous, no human involved here. And dropping with the parachutes. As a skydiver, everyone asks me, what is the most difficult part about being a skydiver? And I'm like, I can't think of any. For me, it's more difficult to board a plane and go through the baggage and the security line. Jumping off is so safe. So using that with the drone that can autonomously navigate and drop things in the right place, can drop a blood in a condition where life needs to be saved. We don't really need a human to be involved, but it can save humans. So just to summarize, this is pretty big, but if you look at every single altitude, there are different set of hardware devices to be built. A crew capsule can be a hardware, an aircraft can be a hardware, drone can be a hardware, which doesn't have to have a human controlling it. And I'm kind of using a blueprint of internet evolution because that's where I started my career. So software actually, if you see, has multiple things. In terms of the C++ compiler, for example, the web browser, it was built in 90s. We need a machine learning compiler. At Singapore Airline, when we were trying to run through algorithms, compiler was a bottleneck. So I tried to find the team that maintains it around the world. And there were 3 people in Microsoft in Seattle who are maintaining that today. And the libraries are built for the user computers. And then equivalent of that is the mobile companies that use another compiler, but we don't have one for machine learning, for example. We also need the hardware. Right now, the crew capsule that goes off with the human flight has about 10 to 12 data sensors. There's nothing else you can change in the flight. But that navigation can be changed with the sensors. So we need to define hardware, software, as well as protocols. We need an autonomous governing body, just like FAA, and that doesn't exist today. But I'm basically kind of bringing it back to you that I would appreciate anyone and everyone who wants to contribute to this new future. Use my doctorate research to take things to the next level. Autonomous technologies are emerging. That's my end again. We need to create a whole new industry, and India is a great place to do it because rural landscape can be saved and used. Call for action. This is the last one for me. What I really feel emotional about is the sun and the solar, which is the future of, I think the previous presentation kind of explained that to you as well. This is a sunset in Himalayas, and this is a sunrise in Andes. And as you look at them, it's the same solar power. So if I'm going to define a software and the protocols, everything, it's not going to be like 15 different AMD chips or Intel chips. It's going to be one solar power. How do we use it, right? So there is a consistency there that can actually play a different role. And that's why that's, again, a small call for action to save the planet Earth and save all the landscapes and be ready to host 20 billion people on this planet Earth successfully. Help me build the autonomous industry. Thank you.